All right, students, matter. Lesson 3, chemical reactions. How are chemical reactions modeled? What is a chemical reaction? Do we remember what a chemical reaction is? Is it different than a physical reaction, physical change? Well, what are we going to talk about this time? That's what we're going to talk about this time. How are they modeled? How do chemists, which are scientists, keep track of these things? How do they write them down? Well, let's see. Let's take a look at the Nearpod. I'm going to do it this way. The wonderful SOLs. And whoa, there's a bunch of them. Actually, we're going to be on this for 2 or 3 classes. Whoa, look at those wonderful bonds. Atoms bonded together. Those all look like gases to me. So those must be covalent bonds from last time. Okay, they're gases at room temperature. H2 is hydrogen, O2. Why does it say H2? Because there's 2 of them. NO2, 1 nitrogen, 2 oxygens. Carbon dioxide, 1 carbon, 2 oxygens. Remember how I said atoms don't like to be by themselves? So here are a bunch of these. How about that? All right. There's another way we look at it. Here we see the chemical symbols, N and H and O and C. OH, that's an oxygen and a hydrogen. So we have 2 carbons, 1 oxygen, and 1, 2, 3, 4, 5, 6 hydrogens. That makes alcohol. Nitrogen. And these little lines, that's for upper level chemistry, but they mean something. But I just want you to see how these molecules come together. They are combined by all sorts of different atoms, and we write these a certain way. We don't draw pictures, we actually write them out. So there we see salt, NaCl, nice little ionic bond. H2O, nice little covalent bond. So here we see all sorts of vinegar. 2 C's, 2 O's, and 5 H's. So if you look, vinegar and alcohol, they're really different, but they kind of look the same. But those little atoms make a big difference. Vocabulary, chemical reaction. The process in which atoms are rearranged to create new molecules. When you do a chemical reaction, the atoms are trading partners. That ionic bond that we like so much, they just broke up. That covalent bond, yeah, they just broke up. They broke up and found new atoms. It's sad, but it happens. Their relationships are over, but they form new relationships. What's important is that the atoms never go away. Matter can never be created, can never be destroyed. Chemical formula uses chemical symbols and numbers to represent a given substance. Chemical equation is an expression that uses symbols to show the relationship between starting substances and the substances produced by the chemical reaction. So the formula, and we'll talk about this in a moment. I shall show that to you like that. What are the signs of a chemical reaction? How do we know we had a chemical reaction? Bonds and atoms are broken. The properties of the substances change. You might see gases formed. A precipitate, a solid, might be formed. The smell might change. It might get warm. It might get cold. Exothermic and endothermic reactions. That's evidence of a change. You might say, I used to have sugar here, but I don't have sugar anymore. That's a chemical change. When the properties itself change. Here is a wonderful video on chemical changes. Now, a reactant, when we write a chemical equation, The reactant is on the left. It's what we start with. The product is what we end with. What's reacting and the product is what's formed. Wonderful little thing right here. You may have seen these before. CH4 reacts with O2. I think we said that was methane plus oxygen. We need to get a little heat in there to get it going. But you can count all these little atoms on both sides. That means it's balanced. So the reactant side, I have 1, 2, 3, 4 oxygen atoms. O2 twice. 2 O2, so I have 4 oxygens. But they're not oxygen and methane anymore. They turn into carbon dioxide and water. That's a chemical reaction. But we still have 1, 2, 3, 4 oxygens, 1 carbon, and 1, 2, 3, 4, 1, 2, 3, 4 oxygens. They don't go anywhere. They're just shuffled around. They make new things. So the reactant is what we start with. This is energy or some sort of thing that gets the party started. And then we have something new, products. A cool little thing. So I don't think I can actually do it because I'm just demonstrating. Wait. Oh, I can do it. Look. Yay. So how many of these do I need? I have 6. Well, that doesn't look right. Oh, hold on. So if I have 4, give me. I'm counting the oxygens over here. Maybe I can, maybe I can't. All right, so I have 2 nitrogens. Now it's balanced because I have 2 nitrogens, 2 nitrogens. You guys can play around with that. How are chemical reactions modeled? Chemical formula represents the substance. It's like a recipe of atoms to make new molecules. Subscript at the bottom tells you how many atoms in the molecule. A chemical equation shows how many chemical formulas, molecules, can be combined to make new chemical formulas, molecules. The reactant is what you start with. Left of the arrow, yield sign or reaction. Product is on what's on the right. Law of conservation of mass. Matter can never be created, can never be destroyed. How do chemical equations show the law of conservation of mass? You have to start with the same number of atoms in the product and the reactants that you have ending up in the product. If you have too many hydrogens on one side and not enough on the other, your equation's wrong. Sorry. You have to have the same number of atoms and reactant. It's called balancing. A coefficient, algebra at some point you might take, is the number in front of the formula to help balance it. Choose your level. So if I have 1 hydrogen, let me give me 4. So if I have 4 H's and 4 chlorines, I have 1, 2, 3. Do you see how it's like 2 pairs of 2? Then I'm going to need 2 pairs of 2. Check. Balance not simplified. Oh, don't give me that. All right. They want it simplified. Yeah. All right. Oh, so they give me a new one. So what I'm doing, I'm trying to, this might be a little above for you guys, but if you want to play around, you're starting to get the hang of it. Here I have a carbon. So I've got to have at least 1 over here. So I have 2 hydrogens and 4 over here. Can you see what I did? 1, 2, 3, 4, 1, 2, 3, 4. I'm just counting atoms. Okay, so law of conservation of energy. Energy cannot be created, cannot be destroyed. An endothermic reaction actually takes energy absorbed from surroundings. Ice does not make you cold, it takes your heat away. Exothermic gives energy. So if you feel a chemical reaction that gets hot, it's giving energy. Some chemical reactions make it cold. A nice little video. Okay, endothermic feels cold, exothermic feels warm. Energy is needed to break bonds. And then what affects the rate of reaction? How much you have, how much surface area, temperature, and catalyst. So I'm going to do another one of these and we'll talk about that. There's a lot in this one. So there we go. The first little bit of chemical reactions. This will be day 1 of it. I'll do a video for day 2, and we're going to keep moving through matter. All right. Thank you, students.